Now we will look at a word problem for the linear function. A new Mitsubishi Galant costs 75,000 dirhams, but every year the value of the car depreciates, means it is decreasing. The table below shows the value of the car over 4 years. Because the value is decreasing, so the rate of change is negative, you can see. Now based on this data, we are going to answer the following questions. A part says, could the depreciation be linear? We know that for the linear function, the rate of change remains same. So for calculating the rate of change means nothing but the slope. It is calculated by the formula y2 minus y1 over x2 minus x1. If the value of the slope is same for all the parts or for all the pairs, then we can say that the given equation represents a linear function. So we will compare it for the different pairs. Suppose m1 is y2 minus y1. First we'll take the first two pairs, so y2 becomes 66,000 minus y1 becomes 75,000 over x2 is 1, x1 is 0. So this value is minus 9,000. The values given in the second row corresponds to the dependent variable or y. The values given in the first row corresponds to the independent variable or x. Always the first row is on the x-axis and the second row is plotted on the y-axis. Second slope is m2 for the second set, that is 57,000 minus 66,000 over 2 minus 1, so this value is again minus 9,000. If I look at m3 for the third set, 48,000 minus 57,000 over 3 minus 2 is again minus 9,000. Similarly, if I calculate m4 is 39,000 minus 48,000 over 4 minus 3 is again minus 9,000. So for all the four cases, for all the four sets, if I see the value of m are same, it means the slopes are same, and so the depreciation is a linear function. What is the yearly depreciation rate? The yearly depreciation rate is minus 9,000. Every year the depreciation is of 9,000 dirhams. Find the formula for the functional relationship between P and T. P is the dependent variable here being in the second row, and T is the independent variable. We are going to solve the C part now. For the C part, the functional relationship between P and T. P in terms of T, because the rate of depreciation, if I compare y equals mx plus b, x is the dependent variable, m is the rate of change, that is minus 9,000 here. Dependent variable is t plus c. C, or you call it b also, that is the intercept. In the table, the value corresponding to 0 is, you can say, that is the value corresponding to 0 is 75,000. So this value is 75,000. This is nothing but the y-intercept or the value of b, the value corresponding to 0. So this is the functional relationship between P and T. For the D part, the rate of change of B with respect to T. Rate of change of P with respect to T is nothing but the rate of change, that is minus 9,000 dirhams in this case, per year. Rate of change is per year. Then is the E part, which says what is the price after 6 years. So the price, P is the price, time is 6 hours after 6 years. So I'll just replace this T by 6 in the given equation. So minus 9,000 times 6 plus 75,000. So I have 9 times 6 is minus 54,000 plus 75,000. So I have 21,000 dirhams is the price after 6 years. For the last part of the question, when will be the price less than 5,000? To solve such question, you have been given PT as 5000 and we have to solve this equation to find the value of T. We have to solve this equation to find T. PT is given as 5000. PT, the equation for PT, as you already know, is given by minus 9000 T plus 75,000. So this PT is 5000 in this case, equals minus 9000 T plus 75,000. So I'll shift this value this side and this value this side. So I have 9000 T equals 75,000 minus 5,000. So 9000 T equals 75 minus this is 70,000. To get the value of T, divide throughout by 9000. So 1 2 3 1 2 3 9 9 1 2 3 1 2 3. You have T equals 70 by 9. So if I divide 70 by 9, divide 70 by 9, 7 times 63, so 6, yes, 7 times 63, you have 70 again, so you have 0.7. So T is 7.7 years, or you can say approximately T is 8 years. After 8 years, the price of the Mitsubishi Galant will be less than 5000.